In the United States alone, each year, about 30,000 people die from infections that originate from catheters. And one of the reasons, the main reason that this happens, is due to a phenomenon known as antimicrobial resistance or antibacterial resistance. And this is when bacteria develop resistance to antibiotics, which is the best way to treat them and pretty much the only way to treat them. And hospitals are a huge cause of antibiotic resistance because you have lots of people with compromised immune systems together in a building, and the bacteria can exchange a resistance to this and that with each other. And once they get that, there's not much you can do. And it's developing a lot faster than we can develop new antibiotics to fight them. There's lots of regulatory hassles, and it's very expensive to develop an antibiotic. So what my project is making a coating that kills bacteria by contact. And I used vegetable oils to make this coating because, number one, they're biocompatible, and number two, they're renewable. So what I did was I modified vegetable oils to have an azide functional group and to have an alkyne functional group. And when you react these groups, they have lots of energy together, you form a polymer. And this polymer has a 5-membered ring with 3 nitrogen atoms in it. You can see it down here. It's called a polytriazole, which holds it together. And this polytriazole, I thought, may kill bacteria. So after I made them, I tested to see if they would kill bacteria. And in the top left, you can see polyethylene, and below it is my polytriazole. And what you're looking at is bacteria under a microscope with a stain. Green bacteria are alive, and red bacteria are dead. And you can see that my stain appears to have killed the bacteria. And if you go over to the right side now and take a look, again, at the top you have polyethylene, and at the bottom you have my polymer. And you can see the polyethylene sample, the bacteria look very healthy and normal. But in the polytriazole sample, you can see holes in them. They're completely dehydrated, and they're dead. This is a scanning electron microscope. And why I use polytriazoles compared to the polyethylene is because polyethylene is pretty much the standard for implants right now. And if you go down to the bottom right image, these are skin cells actually growing on the surface of my polymer, human skin cells. And this suggests that the polymer may also be biocompatible. So you could use it as an implant, or you could use it, for example, as a bandage or an antimicrobial skin dressing. And some of the significance of this research is this type of method to make stuff antimicrobial doesn't contribute to antimicrobial or antibiotic resistance because it kills bacteria by breaking them open when they contact the surface. And being based on vegetable oils, it's also renewable. Thank you.